Hello and welcome to another 2-Minute Tuesday. Since we've been on a roll with our pressurization system videos recently, we've decided to stay with this topic for today's upload. In this video, we're going to run through the stack effect. And by the end, you should know what the stack effect is and why we have to take it into consideration when designing buildings with pressurization systems. So let's start with defining the stack effect. The stack effect, sometimes known as the chimney effect, is the movement of air into and out of buildings through unsealed openings, chimneys, flue gas stacks, or other containers, resulting from air buoyancy. Buoyancy occurs due to a difference in indoor to outdoor air density resulting from temperature and moisture differences. The result is either a positive or negative buoyancy force. The greater the thermal difference and height of the structure, the greater the buoyancy force, and thus we have the stack effect. The stack effect helps drive natural ventilation, air infiltration, and unfortunately, fires. Now, to dive into a little more detail, the main thing that causes the stack effect is extreme temperatures, meaning the seasons of the year affect how air moves in a building. For example, if it was winter and we had very cold air outside a building, what we'd expect is the air inside of the stair core of that building to be warmer and would therefore be rising up the stair core. This would result in there being greater pressure at the top of the stair and lower pressure at the bottom of the stair. This would cause an inflow of air at the bottom and an outflow of air at the top. If the temperatures were to change and it became much hotter outside, then the air in the stair core would become comparably cooler and the reverse would happen. Cool air sinks, so there'd be greater air pressure at the bottom of the stair and less pressure at the top of the stair. Air would therefore travel down the stair core and we'd have an outflow at the bottom and an inflow at the top. It's very important we're aware of this due to seasonal effects causing pressure changes within the stair cores, and we all know by now that the key to a pressurization system functioning effectively is achieving a pressure differential between a fire zone and a protected zone, like a staircase. This means we have to track the seasonal changes and adjust the amount of pressure we're sending to different parts of the stair core at different times. Basically, we'll either be pumping more pressure into the top of a stair core or into the bottom of it, depending on the weather and the pressure changes that the weather is causing. Whilst the stack effect applies to most buildings, it is much more extreme in the case of tall buildings. I'll provide an example of how extreme this can be using a scenario of keeping ground floor premises warm, as this is usually where the stack effect has the most notable effect. So if we consider a 70+ story high-rise building, to maximise their location, the business has entrances at the street and from the building entrance lobby. The business expects high levels of traffic through both entrances, especially in the morning and say in the lunch hour, and calculations would suggest that the building could be under extreme negative pressure when the outdoor temperature drops below -6 to -1 degrees Celsius. If both sets of doors to the ground level locations were open during the morning rush hour, the negative pressure in the building lobby would pull 1,300 cubic meters per minute of air out of the store and into the lobby, whilst also pulling the same amount of outdoor air into the store. If the space volume was around 1,300 cubic meters, then all of the warm air in the space would be replaced with -6 degree air within 60 seconds if the space remained in that condition. So, instantly, that's why many tall buildings actually have revolving doors to reduce the likelihood of two doors being open to the outside simultaneously. Now that's an example in terms of climate control, but obviously we can see what a massive effect the stack effect can have on a building and consequently on a pressurization system. I hope you found the video on stack effects helpful and it's been interesting, and also you understand now why we have to take that into consideration when designing pressurization systems. If you like the video, please hit the like button. If you want more content like this, please click subscribe, and I look forward to seeing you next week. Thanks for watching and bye for now.